All right, so hopefully you've had a chance to look at these next two examples and think about what the units would be in each case. So in example 4, we want to find the units of acceleration given that velocity is in meters per second. So we're told that the velocity is in meters per second and time is in seconds. All right, and we want to know what the units of acceleration are. So we got to think about, okay, what is acceleration? Acceleration is the change in velocity over the change in time. All right, so we can look at the units of velocity. Right, the units of velocity are in meters per second. Now, meters are often abbreviated with just m, and s is seconds. So I'm going to abbreviate it as meters per second. So this is meters per second. And the time is in seconds. Okay, so we have meters per second, and that's the units of acceleration is meters per second. But we don't usually write it like this. So you can treat these units like fractions. All right, so this is the same as meters per second times the reciprocal of the denominator, 1 over seconds, and so meters per second squared. And this is typically the way we would write the units of acceleration, is in meters per second squared. All right, so the units of acceleration, if velocity is in meters per second and time is in seconds, then the units of acceleration are in meters per second squared. All right, so we're treating these units like fractions. All right, so here's another example. Again, this is another little curveball, but the units of electrical energy are in watt hours. Okay, so it's abbreviated WH, but it means watt hours, and it's essentially watts times hours. So this is watts times hours. All right, the units are watts times hours, and that's a unit of energy. And T is given in hours. So we have a function E of T where the energy is in watt hours and the time is in hours, and we want to find the units of the derivative of or E prime of T. So we're looking at the change in E energy over the change in time, right? So what are the units of the change in energy? The change in energy is going to be in watt hours, and I'm going to write it as watts times hours because that's what it is. And then the change in time is in hours. Okay, so it's watt hours per hour, but these units will cancel just like fractions, and it's actually watts. I could write it watts. Now watts is a unit of power, which is the rate of doing energy, or the rate of consuming energy, I guess in this case. I don't know what it means to do energy. It's the rate at which either energy is produced or consumed. So this is power. So this is the amount of power that this refrigerator is using. All right. Now you don't have to know that. That's a physics thing. But those hours cancel. That's the key thing here, is that those we can treat those units as just like we do fractions, and we can cancel. We have hours over hours and the common factor of hours, and so the units of the derivative of energy, when energy is in watts per hour, the units is watts. All right. So you might be familiar if you ever look at a light bulb, right? It gives its wattage, right? That's so like a 60-watt light bulb, which nowadays you can't buy an incandescent 60-watt light bulb, but it often will say that it's equivalent to a 60-watt light bulb, which is the old incandescent power that it was using. Now it uses a lot less energy if it's an LED or something like that, right? But it still gives a wattage on there. So the watts is the rate at which that light bulb consumes energy. And if you look at your energy bill, if you look at your utility bill from the power company, it will give the amount of energy that you used over the month in watt hours, or probably in kilowatt hours because it's in thousands of watt hours. So that's the amount of energy you use. So, all right, that's that's all I have. Let's I'll meet you in the next video for the next example.